We go with 4.07. We're going to be sketching graphs of trigonometric functions, sine and cosine functions by hand, and we're going to show the period, midline, and amplitude. So these are three things, three characteristics that sinusoidal functions or trigonometric functions have, and they're going to tell us a lot about the real-world situations that they model when we start talking about those situations. So it's important that we understand what they are now so that when we are dealing with real-world situations, we can use them to kind of better understand, and it'll help us quickly know some things about the real-world situation we're dealing with. Just want to clarify the connection between the points on the graphs of cosine and sine of x and how that relates to the unit circle, because I know that can be very tricky, and so I want us to be really clear. So let's assume I have some point. Let's start with cosine of x, right? So I'm going around my cosine graph, and let's say I want to figure out a point on that graph. So first I'm going to look at my input value, right? The x coordinate. So the x-coordinate is what I'm going to plug into my cosine function. So I would have cosine of x sub 1. Well, what does that mean? Pause the video now and think about how would you find the cosine of x sub 1? Well, what you're going to need to do is you're going to need to rotate around your unit circle x sub 1 radians. So let's see if we can figure out what that is. Here I'm at about 5.49 or so. And so if you think about that, if you're looking at your unit circle, what would be about 5.49? Well, you can take a look and keep going around, but what you might notice is that 7 pi over 4, well, pi is around 3, so we can estimate 7 times 3 is 21, divided by 4 is a little more than 5, and this turns out to be about 5.49. So that's where we're at. So this is the rotation of 5.49 radians. Well, that is exactly x sub 1 radians. So the correlation is that the input value on my graph is always the number of radians that I'm rotating. Okay? Now, how will I find the cosine of x sub 1? Pause the video and remind yourself. The cosine of x sub 1, which in this case, what's the output? Well, the output is y sub 1. That's just going to be the x value at the point where once I've rotated x sub 1 radians, that I'm intersecting the unit circle. So the input is the number of radians that I'm rotating, and the output, or the cosine of that value, is just the the x coordinate of that point. Okay, so now let's take a look at the sine. So the input here for sine is again x sub 2. It's the same value, right? So that means I'm rotating x sub 2 radians, which is just the same number as x sub 1. So we can just put that in here. That's also x sub 2, or we can write out that x sub 1 is equal to x sub 2. And the sine of x sub 2, well, pause the video and remind yourself, how do you find the sine of x sub 2? Hopefully you're remembering that to find the sine, I rotate that many radians, however that many radians is on my unit circle, and then I look at the y-coordinate of the point that intersects the unit circle. So in this case, the y-coordinate is going to be y sub 2, which is the sine of x sub 2. Okay? So the key thing to take away here is that when I'm graphing my functions, sine and cosine, the input value, the x value here on my graph, is the radian measure that I rotate to find the output, to find either the sine or the cosine. And so that's the linkage between it. We can sort of just imagine that if I'm looking at sine, for example, the sine is just the graph of all the y coordinate points as I move around the circle. Okay, so if I'm traveling around the circle here, I'm thinking about sine being the y-coordinates. So this red line here is a graph of all the y-coordinate points as I move around the circle. And the cosine is, as I move around the circle for different radian measures, what's the x-coordinate point as I move around the circle. Okay? Hopefully that cleared it up a little bit. Maybe rewatch that portion to help you out. But now we're going to move on and talk about specific characteristics of sine and cosine functions. Right, so we have some terms that we are now going to use in talking about our functions sine and cosine. So I'll give you a second. Go ahead and pause the video and just go ahead and copy these down. Now that you have those down, we want to see where they show up in the graphs of our functions. So let's go ahead and let's just graph sine of x on our graph here. So I'll give you a second, pause the video, graph it out yourself. I provided a unit circle here for you, and only graph it up to 2 pi. Alright, so here's the graph of sine of x. And I can just sort of think about my unit circle. So when the angle, or the number of radians that I'm rotating, is 0, the y-coordinate is 0. When I'm halfway to between 0 and pi, that's pi over 2 radians. So when I'm rotating pi over 2 radians, the sine is 1. When I rotate 3 pi over 2 radians, or halfway between pi and 2 pi, right, the sine is going to be -1. So there I've rotated all the way over here, and all the values in between. And we've seen this graph before. Okay? So what I want you to do now is go ahead and try and identify the midline. And the midline is the horizontal line that is halfway between the maximal and minimal line. So go ahead and pause the video and find the midline. All right, I hope that went well. So the maximal point, or the maximal value for sine, is going to be 1, right? That's the max. And the minimal is going to be at -1, right? So that would be the min. And so the midline is going to be in between that, or the x-axis. Okay? So the midline is going to be the line y equals 0, right? That's just the x-axis. I'll just, in parentheses, that's the x-axis. All right, pause the video now, and just ask yourself, what would the midline be for cosine of x, if we graphed cosine of x? Hopefully you realize that it'll be the same for cosine of x. Imagine that I were graphing cosine of x. It starts at 1, right? And it's going to look like this. So it would come down here like that. And the maximal line will still be, right? Its maximum is at 1, and its minimum is at -1. Again, it would look like that. So now go ahead and pause the video and find the amplitude of sine of x. So the amplitude is the distance between the maximal point of the graph and the midline. And you have this word sinusoidal function. And that, of course, sounds a lot like sine, and it's really any sine or cosine function. Okay? And so the amplitude, the distance between the maximal point and the midline. Well, the midline is the x-axis, and the maximal point is 1. So the distance here, I'll use green, the distance is 1. Okay? And so the amplitude is simply going to be 1 unit. All right, now pause the video again and think about what the amplitude would be for cosine of x. All right, so cosine of x, remember the maximal point is still 1 and the midline is still y equals 0. So the amplitude would again be 1 unit. All right, pause the video now and try and find the period for the sine of x. So this might have been a little harder. You want to find the distance between the two consecutive maximal points, or minimal points. So let's just look. Here's one maximal point right here. Do you see another one? All right, well, if I look, there's no other maximal point between 0 and 2 pi. So what I'd like to do is I'd like to find where that next maximal point is going to come. The first one happened at pi over 2 radians. And if I were to continue here, when would I reach my next maximal point? Well, if I think about it, if I've rotated 2 pi radians, so that's all the way around, when will I again reach a sine of 1? Well, I'll have to rotate another pi over 2, or half of pi radians. So if I were to extend my graph out here to 2.5 pi radians, 2.5 pi, and that's the same as 5 pi over 2, if you're counting. Well, when I extend it there, that's going to give me another maximal point. Okay, so I'll have another maximal point here at 2.5 pi radians, or 5 pi over 2. So what's the distance between these two maximal points? Well, this is pi over 2, or half of pi, and this is 2.5 pi radians. So if you were to find the distance between the two, think of 2.5 pi minus half of pi, or 0.5 pi, and you're going to be left with 2.5 minus 0.5 is just going to be 2 pi radians. So the period here is just 2 pi radians. And the way to think about it is, how long does it take for you to return to a maximal point? It's the same as the distance it would take to return to a minimal point, right? So my minimal point is -1, and here I would have to go another 2 pi be off the screen. I have to go another 2 pi radians to reach another minimal point. If I went back in this direction, I'd reach a minimal point at -1/2 pi, -1/2 pi, or negative pi over 2, and that's going to be exactly 2 pi away from 1.5 pi. And the same is true for cosine. So imagine cosine starts at 1, that's a maximal point, and it will come down, here's a minimal point, and we'll return up, and we'll have another maximal point at 2 pi. Notice that I have a max at 1 here, and it goes all the way around, there's -1, keep going, there's 0, and it will return to its maximal point when I get to 2 pi. So the period here would be 2 pi. Graph the function 3 sine x on the interval 0 to 2 pi. Here's the graph. I included a unit circle here to help us out. And so it's just sine of x times 3. It's not that strange of a function. And if it's helpful, you can make a table where you think about the x values that you can easily compute sine with, and then think about what f of x will be for those x values, so multiplying sine of x by 3. Go ahead and try that on your own, and then we'll come back and take a look. All right, so I made myself a little table just to fill in a couple values. So thinking about when x is 0, when the radian measure that I'm turning is 0, so sine of 0, well, that's 0. 0 times 3 is just 0, so that initial point is going to stay the same. When I get to pi over 2, well, sine of pi over 2 is going to be 1, and so 3 times 1 is 3. So when I get to pi over 2, which is right here, that's going to be up at 3. Okay? Moving on to pi, when I plug in pi, when I rotate pi radians, I'm going to have a sine of 0, so 3 times 0 is 0. Back down here. When I get to 3 pi over 2, that's sine of 3 pi over 2 is -1, and so 3 times -1 is -3. So I'll be at 3 pi over 2 down there. And then at 2 pi, back to where I began, the sine of 2 pi is 0, and 3 times 0 is 0. Okay? And we could try a few values in between, but you can probably already see the path that this is going to take. And so we can go ahead and graph it like that. And so now that you have the graph, go ahead and find the amplitude, the midline, and the period for this graph. So remember, the amplitude is the distance between the midline and the maximum point. So probably be helpful to find the midline first, but that's not too hard. The midline is simply in between the maximal and minimal point. So the midline is y equals 0, or the x-axis. The amplitude then is the distance between that and the maximal point, which is just 3. The amplitude is 3 units. And the period is the total distance it's going to take to go from one maximal point to another. And so here I notice I have a maximal point at pi over 2. How long is it going to take me to get back to another maximal point? Well, it's going to be past 2 pi. How much past? Well, think about it. If you rotate all the way around your unit circle, 2 pi radians, how much longer will it take until you get that maximum 3 again? Well, that's going to happen when sine is 1, and so that'll be another pi over 2 radians, or half a pi. And so I would have to extend my graph to 2.5 pi, and that's when I will get back to my maximum value. I guess I should draw this a little better. Back to my maximum value of 3. So it will take exactly a distance of 2 pi radians to get back to my maximum. So my period is going to be 2 pi. So I have a couple more for you to try. We're going to look at the cosine function now. So graph the function -4 cosine x on the graph below. Now notice there are some negative values here too, but we understand how that works. Use your unit circle. I recommend that you use a table to help you out. So pick some x values that you know you can compute cosine of x for, some easy radian values, and then find out what f of x would be in that situation by multiplying by -4, right? -4 cosine x. Once you've done that, I want you to find the midline, the amplitude, and the period for this function. Then go ahead and take a look at the next question, which asks what is the amplitude and period of the function y equals 3 sine of pi times x. I want you to try finding the amplitude and period before graphing it. So only graph after and use that to check whether you were right or wrong. And you might want to notice here that I might change this to be 3 and -3. That might be helpful there. Okay, so go ahead and give those a try. I'll talk briefly about them at the end, and then we'll discuss a little more in class. Alright, so not much I want to say about the first one, except for if I'm thinking about that initial value when I've rotated 0 radians, cosine of 0 is 1. And so -4 times 1 is -4. So we're seeing that we're starting out a little differently than normal here at -4. Okay, but other than that, we should have no problem finding values. So for example, when x is pi over 2 radians, cosine of pi over 2 is 0. So anything times 0 is 0. So at pi over 2 I'll be at 0. At pi, when I plug in pi as my x value, well, cosine of pi is -1. -4 times -1 is +4, and so you'll see that now at pi I'll be up here at +4. Come back down to 0. At 2 pi I'm again at -4. So something like that, and then you can of course plot the similar situation in the negative direction, just like that. Alright, and so then you can use that to find the midline, amplitude, and period. I'll check those tomorrow. And here, the one piece of advice that I want to give you is notice the graph here. I'm going between x's 1 and 2, not 1 pi and 2 pi. So just try these values out in your function, and that might help give you a little bit more of an idea and help you correct your midline, amplitude, and period, and we'll discuss that tomorrow as well.